So we'll start by talking about Java variables and arithmetic operations. In computer science, you deal with data a lot. For example, when someone signs up for a Google account, Google stores their information like their name and age in its servers. If you wanted to make a game that starts by asking the player for their name, and it uses their name throughout the game, you would need a way to store the player's name in your program. This is where you'd use a variable. In your code, you can create variables to store information that can be used later. There are 5 important data types in Java: integers, doubles, booleans, characters, and strings. There are a lot more, but these are probably the 5 most common that you'll come across. So the integer is basically like an integer in math. Integers in Java store whole number values. So for example, if you wanted to store someone's age in your program, you would use an integer variable, which you could reference later on. So you could have 10 or -10 or any number without a decimal as a value for your integer variable. Here's an example of how you would code an integer. You'd start by using the Java keyword int for integer. You have to use int. You can't create an integer variable using the full name like integer. The Java keyword is int. Next, we have the name of the variable, which is age. And this can be anything you want, really. It's just the name. It's for you to understand. So I could have made this age of player or even x. Just make it clear. And then we have our equal sign and then whatever value we want to store in the int. So in this case, it's 11. Now on our next line, we have display, which will just display what's inside the parentheses. And in this case, it's displaying age. So since age is equal to 11, it'll display 11. Now you also might notice there are semicolons at the end of both of these statements. Semicolons in Java are kind of like periods or punctuation in English sentences. You have to end all of your statements with a semicolon or your program will not run. Next we have doubles, which are another number data type in case you don't want to store whole number values. So for example, if you wanted to store someone's weight and you wanted to be specific to the nearest tenth, you could use a double variable type. You can think of doubles as rational numbers if you know what those are. Just like integers, doubles can be positive or negative. So in this code, you can see it's similar to the way an integer was created, but instead you're using the double keyword so that Java knows you want to create a double variable. Next is the name, which we called weight, and then there's the value of 106.8, followed by the equal sign and the semicolon at the end. If you change this double word to int, your code would not run because an integer cannot have a decimal point inside as its value. But if you were to use an integer here, like if I were to say double weight equals 10, then it would work. But when we displayed it, since it's still a double variable type, it would display as 10.0. So these are the 2 data types that you'll need for storing numerical information. Now there's also booleans, which can only store 2 different values, true and false. So it's not like integers or doubles where you can basically store any number you want. You can think of it as a yes or no. So in your program, if you asked the player if they were a boy and they responded yes, you could create a Boolean variable called isBoy and set the value to true. So it's like asking, is the player a boy? The answer is in the value, true, which means yes. If the player responded no to being a boy, the value of the variable would be false, which means no. In this example, there's a Boolean variable with the name child, and it's set to true. When you display it, it'll just display the word true. You might notice that the C in child is capitalized. This brings up naming convention in Java. When you have a variable that's supposed to be multiple words long, like isChild or date of birth or email address, you use something called camel case. Because you can't have spaces in a variable name, camel case makes it more readable and it separates the words for you. So the first letter is lowercase and each word after that, the first letter, is capitalized. You could make this lowercase, it would still run. Java doesn't really care. Once again, this is just for you to read, but it's a naming convention, so you should get used to it. Now, if you wanted to, you could create two Boolean variables. One refers to if the player is a child, and the other one refers to if the player is an adult. Since these two are mutually exclusive, it's unnecessary and repetitive to have both in your code, because if one of them is true, you know the other one is false. To be clear, you wouldn't get an error for having both of these variables, or even to setting both of them to true, even though that's not really possible, because Java doesn't know what these mean. It's just for you to understand, but it wouldn't make logical sense to have true and true for both of these, or false and false. Now, this might be the most common type of data you see: strings. Strings basically store any text. You use quotation marks to surround the text, and then you put anything inside, including numbers. So strings can be used to store all kinds of data like names, birthdays, addresses, emails. If you look in the code, you might notice something different in the first word, the keyword. The first letter is capitalized, unlike the other variables we've seen so far, which are all lowercase. We'll explain why in a future lesson, since it has to do with a more advanced concept, but for now you should just remember that string starts with a capital S, and if you were to write it with a lowercase s, it would not work. So now we have our name and the equal sign, and we have our value, which is Pablo, and it's enclosed in double quotation marks. If you wanted to, you could put a number or something like the word true inside of these quotation marks, and it would still be a string because of these quotation marks. And then we have our semicolon, and now when we display it, the word Pablo will show without the quotation marks. The final data type we're going to talk about is a character. You'll probably see this one less than the other four, but it's still good to know. Characters are similar to strings, except they only store one character. An example of something you would want to store could be your first initial or your last initial. You couldn't store both your first initial and last initial in one character variable, because that would be two letters, and a character can only have one. So we use the keyword char here, or car, however you want to pronounce it, and then we have our variable name, and you'll see the camel case again with the I being capitalized. And then we have our equal sign, and now we have our value. The one character is P, and you'll see that it's different from strings in the way that it only uses single quotes instead of double quotes. This is how you differentiate between a character and a string. So now when you display this, it'll just be the letter P without the single quotes. Okay, so now we have a quick activity. I encourage you to pause the video and try to figure out what each of these data types are. Alright, so first we have 11, which is an integer. There's no decimal point after it, so it's not a double. Then we have, in quotation marks, 124, so that's a string. Even though this value is a number, the double quotation marks makes it a string. Now we have 1.0, which is a double. Even though this is equal to 1, and this 0.0 isn't really doing anything, it's still equal to 1, there is a decimal, so it's a double. Now we have an ampersand, which is just one character, but it has the double quotes, so it's still a string. A string can have as many characters as long as it is enclosed by these double quotation marks. Now we have the number of arms you have. This would be an integer because you can't really have 2.4 arms or something like that. If you were to express 30 centimeters as meters, since there's 100 centimeters in 1 meter, 30 centimeters would be 0.3 meters, so that would be a double. Now we have if you have black hair. So you can think of this as a yes or no. You either have black hair or you don't. So it's either true or false, making it a Boolean data type. Now we're going to talk about arithmetic operations. So just like in math, in programming you use operations like addition, subtraction, multiplication, and division. And there's also modulo, which you may or may not be familiar with. Since these operations are done with numbers, we'll be using integers in these examples. If we wanted to, though, we could use doubles as well. So if you look at the code, we start by creating two integer variables, x, which is equal to 10, and y, which is equal to 5. Then we create 4 more integer variables, which are each the results of the 4 basic operations. I encourage you to pause the video and try to figure out what each of these values will be. Okay, so just basic math. The sum will be 10 plus 5 is 15, the difference will be 5, the product will be 50, and the quotient will be 2. One more important operator you should know is the modulo operator. It gives you the remainder when you divide a number by another number. So for example, if you were to do 8 modulo 3, you would think what 8 divided by 3 is. It would be 2 with a remainder of 2, so 8 modulo 3 is 2. If you were to do 9 modulo 2, you know that if a number is even, it is divisible by 2, but 9 is odd. Since 8 is evenly divisible by 2, it would have a remainder of 0. But 9 would have a remainder of 1. So 9 mod 2 is 1. So you can also change the value of a variable you've already set. So in the code below, you originally create an integer variable x with a value of 10. When you display it, 10 will show. Then you change the value to 20. Notice how you don't use the keyword int the second time. This is because the variable has already been created, and now all you're doing is referencing it and changing its value. If you were to use the keyword int again in the third line, you would get an error because Java would think you're trying to create another integer variable by the name of x, which is not allowed. You cannot have multiple variables by the same name. So now when you display it the second time, it will just show 20. The 10 is completely gone. But what if you just wanted to change a variable by a certain amount? For example, if you didn't have a specific value in mind, you just wanted to increase the variable's value by 10. If you take a look at the code below, you'll see the third line has been changed so that the new value of x will be the previous value plus 10. This will still display 20 on the second display line. This works for all 4 operations. There is actually a simpler way to write this. In this picture, you can see it now says x plus equals 10. This is the same exact thing here, but is the shorthand of writing it. You should get used to writing it and seeing it like this. So this is the same thing as the last slide, but with the other 4 operations. So I want you to pause the video and try to figure out what each piece of code will display. Okay, so once again, it's just basic math. 10 minus 10 will display 0. 10 times 10, 100. 10 divided by 10, 1. And 10 mod 10 would be 0. Now we looked at adding with numbers, but we can also add with strings. Concatenating is just another way of saying adding strings together. Let's say you had 2 string variables, one with the value of hello and the other with a value of Pablo. If you wanted to display one line saying hello Pablo, how would you do it? This would be the code. There are 2 variables, hello and name. In the parentheses of the display, you can use hello and a simple plus sign followed by whatever you want next, so the name. This connects hello and name, and it would print out hello Pablo. The problem is there's no space here. We can easily fix that by having a third component in the display parentheses. It'll just be a simple space. Notice how we didn't need to create a variable for the space. We can just use the plus sign to connect hello to the direct quote, and then another plus sign to connect that to the name. We also could have added a space right here after the O and it would have accomplished the same thing. The same idea can be applied to characters and any other data type. So we can also add strings with other variables of different types like integers. So in this example, we have one integer variable called age, and it's equal to 20. We have a string variable called name. I encourage you to pause the video and try to figure out what this will display. Okay, so hello, and then you use the plus sign and you put the name, which is Pablo, and then you have the comma UR, and then you have another plus sign, which is 20. Even though this is an integer, you can still put it here, and then you have another plus sign to connect this again, and this is what it will show. So now that you've learned about variables and basic operations, you're going to practice writing some actual code. For Java to run a program, you need certain boilerplate code to start. This is what it looks like. You shouldn't worry about what any of this means right now, as it'll be covered in a future lesson. For now, you should just memorize the format of this. The first line is public class followed by the name of our program. You can think of this like the name of our file. For class names, you always start with a capital letter, unlike variable names. Then, you use an opening curly brace to indicate that this class will contain code inside of it. Then you see the public static void main string args. Don't pay attention to what this means, but make sure to memorize this code, because you'll need to type it every time you create a new program. Note that you can't change the capitalization of any of the letters or your code won't run. Then you use another set of curly braces, and this is where you put your actual code, like what was being shown earlier. Notice that after every curly brace, the code inside of it is indented. This is another Java convention that you should get used to. It makes it easier to read. So, as you may have noticed, I've been using the word display to show values for variables. This would not actually work in your code. I just used it to keep it simple and focus on the variables and arithmetic. This is how you would actually display something like a variable from your code. Once again, just ignore the system.out part. In programming, when we refer to something being displayed, it's called printing something. So if I wanted to say, this line displays the value of the variable x, I would just say, this line prints the variable x. Here's an example of a fully functional program. Can you figure out what's printed? Okay, so first we have x, then x is incremented by 20. So now we have a print statement for x. So x is now 30, so this would first print 30. Now we have a new variable being created, which is the value of x, which is 30, divided by 3, so that would be 10. And then we print this new variable y, so we get 10. Now that's all for today. Here are some exercises if you want to practice what you learned today. And the next lesson will be on conditionals.